So then, welcome everybody. Good morning, good afternoon. Thank you very much for joining us today. I'm extremely excited because I have Paul Parkinson here as my special guest. And today we're going to be talking about building multi-cloud DevOps and machine learning ops using Azure with Oracle Database Cloud Services. So just to introduce you a little bit, Paul, welcome. Nice to have you on.
Yep.
Welcome. So you've got quite an accolade. I'm going to just tell the audience a little bit about yourself. So you're an architect and a developer advocate for the Oracle Database Developer Relations Product Management. And you've been in Oracle quite a long time, I believe 23 years. So kind of like my time.
Yep.
Well, the lifers. And typically you in DevRel, you're focusing on full stack development, which includes microservices, data and transaction processing, as well as AI observability and various languages and frameworks. I mean, you've been a developer for a long time. You have quite a accolade in the sense of patents that you have. You've got over 20 plus patents, and you've obviously well known throughout the community as well. So welcome and thank you very much.
Definitely. Thank you.
You're welcome. So today, everybody, we're going to be talking about building multi-cloud DevOps and MLOps using Azure with Oracle Database Cloud Services. Please feel free to post your questions in Q&A, and we will get to those questions at the very, very end, because some may need answering live, typically by Paul, and that's why we'll do that straight at the end. So thanks for joining, and we're going to get into it. Let me just briefly tell you what we're going to be talking about today. So we're going to be talking about the advantages of multi-cloud application development with AI and machine learning, with the Oracle database, and really why people are looking to a multi-cloud platform and the advantages of doing that. And Paul then is going to get into, what is DevOps, what is MLOps, and what's the relationship between the two. And then we're going to go into a DevOps deep dive where we're really talking about implementing an end-to-end solution with Azure DevOps, CI/CD pipelines, vaults, observability, and the testing. And then after that, we're going to really do a little piece to close on the MLOps, which is a subset of the DevOps and how we actually work with that. And Paul's going to do a deep dive on that, which will cover MLflow, Kubeflow, and Azure Machine Learning, as well as with 23AI, which is an important development deployment, as well as machine learning ops with Oracle Machine Learning and 23i, in other words, the OCI Data Science platform. So next slide, please, Paul. Thank you. Sorry, we should have done that one, no worries. Okay. So, safe harbor statement. This is just really a statement to say that what we will present in general is a product direction and cannot be written into any contracts. It's confidential information under NDI, as we have with our customers. And any information we have present here may be subject to change. So you can't really sue us or hold us to that, whatever we're saying here. So that's the crux of it. So the next slide, please, Paul. Thank you. So let me just begin we're just going to talk and set the stage really about the advantages of multi-cloud application development, and just tell you a little bit about what we as Oracle have in an Azure cloud service environment as well. And then we're going to talk about the various aspects of, what we have within Oracle, in addition to the cloud services with respect to the database development and the machine learning. And then I'm going to hand over to Paul to really talk about the ins and outs of the DevOps and the MLOps as well. So next slide, please, Paul. Thank you. So it's got a build, so we'll just let this one build. Okay. And if you go one more, that's it. So what I'd like to just briefly go over now is just really what we're doing here within Oracle, because multi-cloud really is at the heart of our it's the core of our strategy, really, in all things that we do, in all aspects of development, in the way in which we're enabling you as a customer, or to give prospects looking at our cloud services, more choice, and to think, oh, well, maybe we could come over and see what Oracle is offering, in addition to actually being able to deploy your application on your favorite application development platform as well. So really, it's about how can I build applications once and deploy them on any cloud or virtually in any environment. So every cloud service provider, as we all know, has got a multitude of cloud services. And that, really the goal here is to create applications that leverage the best of both worlds, whether this is on the application side or on the data platform side, that enables you to also be cloud neutral by having a multi-cloud strategy, but also have this flexible deployment as well. So in terms of data, every organization needs to plan, create, and understand and control your most valuable asset, which is the data. And the goal is to do so better than the competition. And the problem today is that we have this onslaught of data in so many different formats. It's very difficult to make sense of it all. And really, our data is not valuable if we cannot separate valuable patterns from the noise. And this is where our session today is going to talk about how multi-cloud application development, how we can standardize with DevOps tools for CI/CD, and what how we can actually bring any clouds together to give you the best of both worlds. Next slide, please, Paul. Thank you. So on our multi-cloud happenings sessions, in the past, we've focused very much on Oracle Database at Azure. And for those who were not familiar with the service, this is really a service that we have forged in our partnership with Microsoft, which enables us to run Exadata database service, Xlime hardware infrastructure delivered into the Azure data centers, and enables you also to run the Oracle Autonomous Database serverless as well. So the idea behind this is by putting this hardware into the same data center as your data center in Azure, you should expect the same low latency as your other Azure native services as well. And what we've done by this engineered interoperability and this integration is that we enable you to easily provision in the Azure portal. So you've got your usual native Azure interface, yet you can unlock the best Oracle database performance, high availability, scalability, and that enables you then to use RAC as well as you previously weren't able to in Azure applications. And we did a little bit more on the commercial side by ensuring that the partnership delivers unique benefits. So you can procure this service in the Azure Marketplace with one unified bill, so you're not dealing with the two cloud providers' separate bills. And you can also leverage Oracle licenses, BYOL license included. We have collaborative support, and the Oracle support rewards also apply. And you can use your Azure commitments, your MAC as well. Next slide, please, Paul. Thank you. So another alternative we have for using your applications, developing in Azure and using Oracle Cloud Interconnect, or the Oracle Interconnect for Azure as it's now called. This enables you to use our OCI services. You can have a split stack deployment, say, for example, with your database services deployed in Oracle Cloud Infrastructure. And this really was forged as part of our partnership. This was the first service that was forged as part of our partnership with Microsoft, where we created a cross-cloud private interconnect, which is a dedicated private interconnect, which negates the need for a connectivity provider and enabling you to set up cross-cloud workloads without the traffic going over the internet. And that's available in 12 regions. So what that means consequently is that users can build and deploy Azure DevOps CI/CD pipelines with Oracle Exadata database service, or base database service in this case, or autonomous as well, and whether that's serverless or dedicated. And you can actually deploy and configure this to support virtual networking to enable a split stack deployment across a high performance interconnect to provide this application development environment, and to enable you to run cross cross workloads, cross clouds. And this is a little bit different, obviously, because this is very separate. It's not deployed in Azure, it's deployed in OCI, and it has a private interconnect, and you pay, as you can see on the slide, you've got bandwidth options of 1 gig, 2 gig, 5 and 10 on pay-per-use charge, on your port charges, but all ingress and egress charges do not apply for traffic going over the local, over the interconnect using the local SKU. Next slide, please, Paul. Thank you. So you've probably heard a lot about the Oracle Converged Database, which is something we've been talking for a couple of releases now. And what we're doing here is we're offering customers the world's best converged database because it has native support for all modern data types and the latest development paradigms built into a single product. So not only are the data types and paradigms available in this converged database, but they've also been engineered to work together. And we do spend a lot of time ensuring that we're building new and more features to enable developers to seamlessly mix and match data types and models. So what that means, for example, is you can, with the converged database, we have support for spatial, which Paul will mention later as well, for location awareness, JSON for flexibility, Internet of Things for device integration, memory technologies for real-time analytics, and traditional relational data, of course, as well. But by converging this, we can run all sorts of workloads from geo-distributed blockchain to analytics and machine learning. And it can, it can give you a lot of power and flexibility as a developer to implement and actually have very, you can span different models and create a lot of power, whether that's invoking graph or JSON or key value pairs, for example. Next slide, please, Paul. Thank you. So now we get on to 23 AI, and we just wanted to touch on this a little bit, just because we will be talking later on about 23 AI, and just to introduce this and to take it a step further in the sense of the 23 AI next generation converged database. We've put a lot of development into this. AI introduces over 300 new features and enhancements, focusing on architectural simplicity and scalability for data-centric applications. Now, the three key innovations that have been long-standing data management challenges that we're trying to address with this release, and have very, very powerful features. The focus is really around these. So the first is JSON relational unification, as well as the graph relational unification, to simplify data management, enhance data productivity by allowing you as a developer to treat data as relational, JSON, or graph. And this is really huge because it enables us to treat data in different ways. And like I said before, it allows different problems to be solved through this unification. And data in this format is associated functionality for the database, or it allows us to ask different questions or answer very complicated questions in a much simpler way. So the third innovation that we've put a lot of development on, as I mentioned before, with these 300 new features, is the AI functionality. And that really opens the door for data to be analyzed and used in ways that were not previously possible. So, whether you want to leverage data that's already in your database or combine it with data in your database with AI services, you can now have this possibility of deriving new value from data from the Oracle Database 23 AI. Next slide, please, Paul. So just to touch on that a little bit more, in the sense of the native AI is all built into the Oracle database. And enterprise AI is all about boosting business with artificial intelligence. And Oracle Database 23 AI is making sure that your AI solutions are easy to build, but also easy to use. And these capabilities have been built in with AI vector search, as well as generative AI, which allows for models to generate code, text, and other data in response to prompts. And it means that you can simply ask the database in natural language, as well as generative AI, select AI, and autonomous database results are returned, or SQL queries. And AI is not new to the Oracle database. You probably heard of Mark Hornick, one of our esteemed product managers. He's been working on this for many, many years, and we've now really got to the point where we've got such rich experience in features, which we've put into the development over the last 20 years with machine learning and in-database predictive models. Next slide, please, Paul. And just to finish on that note, I'm just going to mention the fact that we've got the Oracle Machine Learning, because Paul is going to be talking about aspects of Azure, but we just want to talk about the Oracle side as well. And this really supports data exploration, your preparation, your machine learning modeling at scale, whether that's SQL or Python, REST, automated machine learning as well. And it delivers over 30 high performance in database algorithms, producing models for immediate use in your applications. And this is obviously accessible through multiple language interfaces. And being the next data database product manager, I just want to point out as well, we have this storage tier optimizations, which enable function push down for high performance inferencing as well, which means that we've got all the AI goodness included at that level too. So by keeping data in the database, you can simplify your overall architecture and maintain data synchronization and security. It enables also data scientists in your organization, as well as other data professionals, to build models quickly and simplify and automate key elements of the machine learning lifecycle. Next slide, please, Paul. So now we've explained a little bit about multi-cloud, what we're doing, why it's so important for us within Oracle, and touched upon the features within the Oracle database. Paul is now going to be discussing this in more detail, and these solutions that he's advocating would use either the Oracle database at Azure service, or they would use the Oracle Interconnect for Azure, which is why I've just briefly explained the differences of those two up front. And Paul, when you get to that part, you just say provision either one. Okay. Okay. I hand over to you. Thank you very much.
All right, excellent. Yeah, thank you, Suzanne. And I am super psyched about doing this because probably people on the call know this, and everybody at Oracle knows Suzanne's the multi-cloud expert. So it's been cool working together the last year or so on these topics. Yeah, so I'm ready. Let me dig in. And this is a lot. I'll warn you all up. This is a lot of material I put in here.
Okay.
Exactly. I was going to say, hold on to your seats. Maybe both.
Yeah, we'll try and do Q&A at the end. We'll try and leave some time for that. If we're getting to the point where we're, you think it's running a little bit short, Paul, maybe we could just have a rec and see if there are any questions and answers, but we'll see how we go, okay?
Exactly. Yep. Okay. Great. Okay. Perfect. Yep. And I'll go is high and low on this presentation.
Yes.
So
we've got
you'll get a lot of information.
Yeah, exactly. We've got key links at the end, which go into details on where you can get more information as well. Yeah.
Yep. Perfect.
Questions in QA. Thank you.
So what is, start at the beginning, what is DevOps? And probably know the general nature of this. So it's a combination of dev and ops. And so now you have two jobs. And it's kind of the life cycle is, I'm going to go into in a little more detail in a bit, but this is the general life cycle where you're developing, deploying, testing, monitoring that, and then you start the cycle over again, okay? And so this continuous delivery and integration is CI/CD, and we'll get into more details. So what is the relationship between DevOps and MLOps? Well, they are very closely related. And the long and short of it is that MLOps is kind of a specialized DevOps. So it has all the same principles of DevOps, but of course it's applying to models. You could say instead of applications, but it may be even in addition to applications. You're developing models and those models are used in your application. And so that's why the diagram kind of looks like this. And then LLM ops, we won't bother to go so deep into that because that's essentially just a specialized ML ops for large language models. Okay. So, as Suzanne was mentioning, ML is, a lot of people refer to ML as, traditional AI because it's like smaller models, maybe a more specific subject type, whereas LLM is large language models, as the name suggests. It's, larger data sets, language-based, etc. So that's kind of the relationship. And then as far as MLOps, we have the same idea as DevOps, but slightly different components to it, where you're doing data collection, then you're processing it, testing it, deploying it, and then starting the cycle again. And as I say, I'll go through each of these steps in a later slide. So why multi-cloud for DevOps and MLOps? Well, it's the best of breeds. The whole multi cloud thing is so great for architecture and developing these, because you can pick things such as Azure Machine Learning, which is so popular, but use the Oracle database, and all of these are very popular for good reason. And so just the nature of multi-cloud certainly applies to DevOps and MLOps. And we'll get into that, that'll be illustrated as I'm talking about this, using Azure for your application, Oracle for your database, that type of combination. It's very, very powerful. And certainly the same holds for MLOps. Okay. So now let's get into DevOps. So this is that same life cycle. I'll just elaborate a bit on what these phases are. So in the plan phase, you're doing, what do you want to do next? And what bugs are you going to fix? What's the next thing you're going to roll out for your release? And that can also include infra. So there is a kind of, on-ramp step of setting up certain infra. You're not creating your infra every time you do this cycle. And what I present here applies to all the, maybe the 80%, but for every company and every, kind of project, the CI/CD and DevOps is a bit different. And a lot of people roll their own and things like that. So I put it, that's what that asterisk next to infra stands for, because for some, and when we get to the build and things like that, some companies will provision a whole database, do the testing, and then deploy. Other companies will provision, that's, again, the Oracle database is awesome because you have the PDBs. You can provision a PDB. It's like a perfect way to do your testing. Provision the PDB, or have a PDB for development, for production, etc., or even just schemas. So my point here is that you've set up an infra, some sort of infra ahead of time in almost all cases. And that's what I'll go through in a little bit too. Then you do your coding and develop. That's pretty obvious. You're doing your coding. Then you do your build. That's where you're committing your code to a repo. And the other aspect that's kind of variable in the different DevOps setups at various companies is where testing is done and how it's done. So testing is done as part of the build. Your unit tests and things like that are part of the build. But then you move also, then you move to the build where you commit your code to the repo. That triggers, the pipeline and various actions that I'm going to go into, including testing. Then you move on to the official testing phase. And that may be, you've done the unit testing and build, but now you're rolling out to your QA environment and doing testing there. And then even after the release, you'll be doing testing. And there's certainly not going to go into all the different testing types, but you'll have blue, green. You can have mirrored testing where the same traffic is going to production and to your QA. So I just want to make the point of the kind of variable nature, but this is the general flow. And so your code is tested. Then if everything goes well, it's released to production. Everything's actually pushed out to the public in the deploy stage, and then it's live. So you may even be doing config and testing while it's live, as I mentioned, and you're certainly observing the behavior of your live production, and then you go back and do your planning based on that observability. So we're going to go into each of those steps as I now dig into the particulars of setting that up using Azure DevOps. That's super popular. The Azure pipelines for DevOps pipelines, extremely popular. So first thing, as I mentioned, you're provisioning your basic infrastructure before all of this. And in this case, we're setting up a Kubernetes and a container registry. So this, you don't necessarily need to be using Kubernetes and container registry, but this is the very popular standard for microservices and things like that. So this is very easy. You set up a resource group. If you're used to OCI, it's pretty much akin to, say, a compartment. And you're just going through and either using Terraform, infrastructure as code, or clicking through the console. And I have a couple console screens here. So there's no need to really go into this too much. Your user needs to have the privileges, obviously. And then you're going through and just saying, create a Kubernetes cluster in Azure, and create a container registry. That's where you would store your images that are used by your Kubernetes deployments, by your microservices, or whatever your app may be. Okay, that's what's going on here. That's pretty straightforward. You've provisioned. Then you're provisioning your database, and Suzanne covered that. And then you can connect, you're setting up your connectivity between the application and the database. And you do not necessarily, you don't need to use the Oracle operator, but there is a very robust Oracle Kubernetes operator. So operator is kind of a standard resource in Kubernetes. And most companies have created operators. And as the name suggests, basically that's taking admin jobs, responsibilities, and automating them in a Kubernetes environment. So the OR operator can be used to provision or provision a database or bind to a database that already exists, and do upgrades and things like that automatically. So the instruction, you can check this out on GitHub, and the instructions to deploy this are quite simple. And then you just bring in credentials for your OCI, and you're off and running. So that's the long and short of that. Then the next is, and this is the interesting point. This is the interesting point and very secure solution for connecting your app to the Oracle database if you're using Azure DevOps and pipelines as we are here. So again, there are different ways, different possibilities. But if you're in the Azure DevOps, development environment, you may be using Azure Vault, and this applies even if you are not. You're using app config for your application. Okay, and so what you have here is you go into the Azure and create an app registration, and then you create a vault and you create your secrets. Okay, and these, again, I won't go into these because these are click through, create different types of secrets depending on if it's a password or whatever. But that's the long and short of it. You have an app registration, and then you're creating these secrets in a vault. Then you go ahead and create your pipeline. So you start with your source repo, okay, that you've been developing in. So it's kind of a natural process. You go into Azure pipelines and say, okay, I want to make a pipeline out of this source code, out of this repo. So you point to the repo, and you can then add to your pipeline, which is the thing that's going to do, the majority of those steps I mentioned in the DevOps flow. You create that and add any variables you need to with it. And what that does is generate what is the core file for DevOps, which is Azure pipelines.yaml. And same idea with OCI DevOps, where they each have a whatever pipelines.yaml, and that's where all your pipeline information is, right? So the Azure DevOps provides the ability to they have some wizards where you can say, I want to add this, I want to add that, or you can just obviously manually edit that YAML file. And this is an example on the left of, in that pipeline YAML, you have these different steps and stages. So this is a snippet of the deploy step, and this is manipulating the Kubernetes deployment that represents your microservice. And so that's one of the stages. So on the right, you can kind of see all the different stages in the pipeline basically line up with a lot of what I talked about as far as the build stage. You have your build, your deploy, you're downloading the artifact from the container registry you created. That image is used in your Kubernetes deployment. You're getting the environment variables, and then you're deploying to Kubernetes and doing whatever testing, etc. So fairly straightforward in reality. And then this is, I just wanted to point out, this is a Java example, but this is an advance in the last year or so where, obviously we are completely in sync with Azure and with security and connections. So this is really nice. This is app config and the use of app config providers with the Azure Vault. But as I say, you can use this with other vaults and things like that. But in this case, it's the Azure Vault. So as you see here, very simple. To make the connection from your application, you're actually just referring to app config that's in the Azure DevOps system that we saw on the previous screen. You set up this config, you set up that points to your vault secrets, and then all you have to do in your code is point to multi-cloud app. So you know, in general with programming and microservices in particular, you don't want to touch your code with any particulars of variables. So as you see here, there's nothing going on as far as specifics of the variables used to connect. And this is the key part as far as security, because this provides the most secure way to access things in Kubernetes, because there are a lot of ways to be less secure, put it that way. So for example, in Kubernetes, you have secrets. By default, those secrets are just base 64 encoded credentials, and that's what's out there. So, yes, you need permission to have Kubernetes permissions to look at that, but if you do, it's exposed. And then the next one is there are different techniques that they have in Kubernetes to bring those, this is your URL and password and everything, extremely sensitive information into your environment, but that's still in the environment of your container. So that's not great either, because if you can get into that container, it's exposed. So what's great about this is you're running in the environment. You need to have the privileges of the Azure environment, the role, and then you're just giving this key to access that information from the vault. So it's extremely dynamic and the absolute safest way to connect, because there's no environment variables or anything like that. You're going directly against it. And you can do things on the back end, like rotate the wallet and the password and things like that. So I spent a little time on here because it just really speaks to the security of this solution of this multi-cloud application here. The other thing I'll spend a little time on, because it's completely unique to Oracle database, and now we're on that last stage of observability. You've deployed to production and you're observing, or you're observing even in your test environment. And that is something I've been coordinating other people's work more than anything, but a solution across Oracle for observability. And so I talked to all the groups in Oracle, and they're all in sync with this solution, which is based on OpenTelemetry, which is the standard for observability for metrics, logs, and tracing. And so everything is OpenTelemetry based. And we have exporters for those, what's called the 3 pillars of observability: metrics, logs, and tracing. And it's very cool about the Oracle database is you define what you want as far as what's exported using SQL. So that, gives you the utmost control over what metrics you want, what logs you want, what tracing you want. For example, with logs, you could say, I want this particular information from my alert log specific to this application, and then I want this trace information from the logs, etc. And then you can get a very fine amount of information. Again, there's so much data. That's something that's very desirable to have, just what you want. And then all the metrics, logs, and tracing are combined with the app tier so that you have this end-to-end solution. Okay, so you can look at one console, whether that's like open source Grafana or Azure or OCI's observability solutions, operations and management solutions. You can look in one to see across the tiers. Okay, so that's impressive for metrics and logs, but tracing in particular is very impressive, because tracing is kind of a special beast, because metrics and logs are just grabbing the two bits of information from the app tier and the database tier and putting them together. But tracing is actually, you have to show the relationship through the system. So you have to show how it propagated through the system. And so that the two aspects of that propagating of the information and the exporting of traces from the database in open telemetry format are two things that Oracle has that no one else has. And what that allows you to do is to have a trace from your app tier into your database. And again, this is only Oracle has this, and I'm super psyched about this because we've been working on this for a while and it's now released. In most cases, when the poor DevOps people, they're looking at their consoles and they're looking at the app observability, and then it comes over, they're tracing the trace, and then it comes to the database, and there's a big node there, and it just stops. And they scoop up all their IDs and they go over to the database observability tools and they correlate. So, you can see that that's a pain. The best case scenario, that's a pain. So what we've done is, as I say, it's two parts. In the drivers, we've allowed the propagation of that OpenTelemetry tracing ID into the database, okay? In a similar way, if you know about the ECID that's been in the database for a while, that tracing into the database, we've, reused that. And again, with the converged Oracle database, there's so much expertise. We talked about, Suzanne talked about ML has been in the database for decades. There's so much in there already that we can draw upon. And these standards, some of these standards draw upon the database behavior. So these open telemetry standards are definitely influenced by Oracle database tracing. So anyway, the first part is the drivers are propagating the trace ID into the database. And the second part is the database is exporting these traces to the trace collector. Meanwhile, the traces are being exported from the client side and they're put together in the tracer so that you can view end-to-end traces and like any amount of detail in the database, from the cell phone into the database, into the disk, all in one console. So super powerful for DevOps. And, again, you can be using your Azure DevOps going to your Oracle database and achieve this. So DevOps people love this, of course, because this is, it makes life way easier. And then finally, I just wanted to touch on the fact that we have, when you set up Liquibase for CI/CD, and we have that built into our SQL CL tools, but you just add that as a script. You just add that as another part of your pipeline. So I've been talking about the kind of code change scenario on the app tier. The same applies for the database tier. So you have CI/CD on the app tier and the database tier. And, a lot of your apps may be running in the database, especially if you're using Oracle. Because with Oracle, you can even run Java and JavaScript in the database and Python executions in the database. So full solution. So that's the DevOps story. And now we build on that for our MLOps deep dive, okay? And so again, for MLOps, we have this flow, but it's slightly different. The first stage is the data collection. So this is the data is coming in, it's being ingested and cleaned. And so, and then kind of that works hand in hand with the next stage, which is data pre-processing. So you're wrangling the data from, potentially different sources and engineering that data, et cetera. And so this is your, where your ETL is coming in. And it's kind of another advantage if you're using the Oracle database is a lot of this cleaning up and stuff like that can actually occur in the database or can occur and then be placed in the database. I'll talk about a few products that do that. The data is cleaned and then put into the database. But the ability to structure data and to query data, as Suzanne was talking about earlier, the graph, relational, and JSON, the fact that that can be all stored in one spot optimally in a relational format, but accessed in different ways, helps facilitate this as well. So the next stage is training. So that's where you're developing and training, and you're more than any, probably more than half is tuning parameters of your model. And then you're testing, so you're scoring that model using a different data set, control set. And then, based on that, go ahead with deployment into production and integrating with existing systems. Like I say, whatever those systems may be, even applications that are now using your models. That's why it's, there's quite a relationship with DevOps. Then you're collecting the feedback and monitoring that, and you're checking for data drift. Is the model still relevant to the more recent data, and aligning with business objectives, and start it over again. Okay. So now I'll get into some of the popular data science services. And certainly Azure Machine Learning is extremely popular for data science. And I just grabbed this image on the right-hand side here to show, what that provides. And that basically coincides with the life cycle that I just mentioned, right? Data preparation, build, managing the compute, training it, things like that. And then OCI Data Science is completely, it can do that. And so that's what I show on the bottom right here. You're able to go with your Jupyter notebooks and try out different experiments and things like that for the pipeline. So they're used to develop, train, tune, and deploy ML models. And then the data can be obtained, as I say, from the Oracle database, which can also do the data collection, which I was just mentioning, can do cleanup, pre-processing, allow, access of the data. And then OCI Data Science can be used with OCI Data Flow. And so that's the Spark service, basically for ETL, so mass ingestion, or ingestion of mass amounts of information and cleanup. They can go right into data science or into the Oracle database. So that's kind of my main point as well with this, is there are definitely the most popular ways of doing this, of doing all this data science modeling, but there are a number of different combinations that you can have as well. Okay, so you can be using the Oracle database just in this fashion, not even using OML to have these advantages, or as I'm going to go into in more detail, using OML. Okay. So I'll just very quickly, MLflow and Kubeflow. These are similar to the data science platforms in OCI and Azure, but these are open source. So they can actually be used together. That's why I say there's a lot of different combinations, but generally these are used when you're not using OCI Data Science or Azure Machine Learning. This is just like every solution, you have the cloud solutions, which have really nice integration with their other cloud services. And then you have this is kind of the Grafana of data science. This is the open source. You may have a bunch of different data science things, and this is, it's pulling from different environments. So that's why I kind of put in bold, they're all doing tracking projects and models. I put in bold the fact that, it's ensuring reproducibility across different environments. In other words, it's purporting to be more portable and, easier to share because it's this open source thing, but you're not getting the niceness of the cloud services hooked into it. Okay. And MLflow and Kubeflow are very similar. Kubeflow is more tailored to Kubernetes. They both run in Kubernetes, but Kubeflow has additional Kubernetes scaling, et cetera, functionality. So those are the most popular. Now, if you didn't know, that's the most popular, is the two data science platforms I mentioned, and MLflow and Kubeflow. So the database supports MLOps, and I'm going to go into some of the details of how it does that with OML and 23AI, and how it's, this is not an accident. This has been, planned over decades, as I say, but especially with the 23AI release, we have, some really nice MLOps features. And so here, these are some of the basics, and I'll go into more detail. I'm not sure if I talk more about AutoML actually. So very quickly, AutoML is the OML is in the database ability to pick the most optimized models based on your data. So that's a pretty awesome feature because it cuts out multiple steps. You'll see if you use it, it'll be like, okay, here's your data. You'll go through this step, pick the algorithm, try the algorithm, things like that. But the rest I'll go into more detail here. So this is a bit of an eye chart, but this is shows a lot of the OML features on one page. Okay. So we saw how the data science platforms do this model registration and versioning. If you're using OML services, you can do the same thing, and you can import very easily any model. You find a model on Hugging Face, there Onyx is the standard, import it, and now you're using it in the database. And again, using it in the database right next to your data. So this is such a huge advantage that just keeps repeating itself in anything you do with the Oracle database. Is the data is right there with the model. You're not shipping things around, and I'll show that with some of the 23 AI features, the advantage of that as well. So you bring in your Onyx formats, and then we have the built-in models in the database. As we were talking about, the spatial AI is one of my favorites because in 23 AI, they brought in a lot of predictive forecasting models into their database. Super powerful for doing spatial. And, that sentence doesn't do it justice, but that's just, an example of native OML processing. Model deployment, so you have in-database models, and they're immediately available using integrated SQL prediction operators. So again, this is another advantage of the data is right there, and you can use SQL to operate. You can use Python, and I won't go into OML for Py, but that's the ability to, run Python in the database. So anything you're doing with your Python today, if you're not using Oracle database, you just bring that into the database and it'll work. Any of those models, anything with Jupyter Notebooks or Python you're doing, you can use that in the database with OML, and it will actually run the execution in the database. So you don't have to have CPU on your laptop. You run it in the database. Okay, that's the long and short of that. It provides real-time batching and scoring. AutoML. Okay, I did talk about this already. AutoML. Model monitoring right in the database using all our monitoring tools. Workflow orchestration, so you can do whatever you want in the notebooks, and they're sitting right in the database. And then governance and security. So we have all the Oracle database goodness as far as security. And just like with DevOps, having that Oracle security, and then you're reusing that security, so you don't have multiple things to maintain as far as the security. That's just an implicit benefit of using the Oracle database. You're not using your credentials from here, credentials from here. It's all in the Oracle database. Okay, so you can see how this lines up. You can use OML with the data science platforms and Azure, but it essentially replaces them because it's had these features for, so some of these are new, like the OML surfaces and things like that, but a lot of these have been around for a while. So it makes it, very, very much an alternative or something you could add on to your existing data science. Very quickly, there are a number of features in 23 AI around AI, but one I mentioned in this context is retrieval augmented generation. And so, we're all using ChatGPT and all these LLMs and things like that. But of course, when you're using that, that's public and your data is going out there. So one of the advantages of RAG is the ability to use these models, but use it with your private data privately. And so it's more relevant to what you're looking for, and you're not sharing your data, and you can trace the reference to a source, provenance, okay? And so you're not getting hallucinations and things like that. You know that you can trace the source back. So the big thing with the models is we're talking about OML, but what if you're using some model that's out, like Oracle's OCI, which is based on Cohere, or any of these other models? You can use your own data. That's kind of the very long and short of it. You can use your own data to supplement it without retraining the whole model. So the model has been trained, but you're providing your private data and using that model. Okay. So again, just very quickly, this is the multi-purpose converged database advantage. Other solutions, if you're using Pinecone or something like that, you're shipping your information out to the vector database, vectorizing it, and when you're using RAG, you're using embeddings. So you're converting your data to vector embeddings. That's the long and short of a vector database. And so In most cases, if you have your business data in one database and you're sending it to a vector database, you're sending your information back and forth, and it's the whole converged advantage again. You don't have to manage this. You can use the transactionality. That's actually why I joined Oracle 22 years ago, is because of the transactionality in the database. That's my background. So all of this stuff, what you're using spatial with JSON, with vector, you can make all the changes transactionally, which is huge because then when you're acting on data, it's in sync and it's the latest. So as soon as a query comes in, your vector database is transactional with your business and you're not shipping it back and forth. It's a massive advantage. And so my main point with this in the context of OML, or in the context of MLOps rather, is that you can also be using LLM ops along with your traditional ML. So these are just code examples of, loading in a model. This is a one-line thing. You found a model on Hugging Face you like, load it in with this code, run a sentiment prediction with this one line of code, and then add in RAG to say, in this case, I'm saying stream in for information about the financial market using this Onyx model I imported, and then combine that with my own private financial information, put the two together and tell me, and this disclaimer, don't use this. We're not allowed to say use this and you'll get rich. But just, this is a mechanism to show that you combine these two types of information, these two different types of models in your ML ops to, provide information. So I hope that wasn't too much of a ramble. And with that,
thank you. Well, great.
Cool. Yeah, thank you.
So we don't have any questions yet. If you do have any, I'll just go through a couple of slides to close. If you want to think of a few, you've still got time to put them in Q&A. We've got 7 minutes left. Thank you, Paul. That was really wonderful. I think, for people who've not been exposed to this before as well, it gave a wonderful insight into the whole start to finish cycle and what we're doing in Oracle as well within the database, right? Features that we apply immediately on the data rather than, that point you made about the transactional aspects, and the data has to be relevant, real ACID transactions, as database generally do. But the problem is they're not applying these attributes and this functionality real time onto the data. And like you said, you have to fetch the data to another platform, which will do the processing of that AI ML. So I think this is what we're really focusing on within Oracle is, like I said at the very, very beginning, and also like you also said, Paul, when you just covered your last slide, is that we really let the data work for you, because we're bringing all this rich functionality to the data. So this slide really is showing you where you can learn more information from the topics we covered today. And we've got the 23 AI. I've also included the 23 AI free, which is paramount for developers, and included the OCI DevOps, what we're doing there. You can take a look, as well as if you're already familiar with the Azure side of things. And also, Paul, you've worked extensively on a workshop in the live labs as well, which we've included. And we collaborated together with Leo, didn't we? Leo Alvarado, on the reference architecture for building DevOps CI/CD pipelines for Oracle Exadata database service, as well as Oracle-based database service, which was awesome. And
I know, I wanted to give a shout out to Leo, so I'm glad you did.
Yeah, of course, we can't forget Leo.
Right.
Never. So Leo is in my team, and we collaborate a lot with Paul to really look at collateral we can work on in terms of assets for developers, and with myself with a multi-cloud aspect to it. And we've included just the homepages for the OCI Data Science, Machine Learning, but also a couple of live labs to get you started and a beginner's introduction to Oracle Machine Learning fundamentals on autonomous database, serverless, as well as Python as well for the autonomous database as well. So next slide, please, Paul. Thank you. I just included this sheet at the end just because we've been talking about the Oracle Machine Learning interfaces, And this really just table captures the platforms where the Oracle Machine Learning components are available. So you know specifically on which platform they're delivered. Next slide, please, Paul. And next slide. We're going to the end now, and just wanted to shout out that we have our team Slack channel. Before we get to any questions, if we're lucky to have any, we haven't got any yet. But we just wanted to say that you can post anything, topics that you would like to in this Slack channel for discussions. It's really to engage us as database product managers within the cloud services. So in other words, in my team, and I'm supporting Exadata database service, base database service, cloud at customer as well. And we also have liaised on a lot of work with the AI chatbots called Ask Ed and Ask Debbie for questions on the DBaaS CLI and OCI CLI as well. But it's important to just mention that within this Slack channel, we're broadcasting announcements. And when we publish blogs, we tend to put them in there as well. So to save you some trouble to keep everything in one place. So I think if we just take a quick look now, we don't have any questions at all. Is there anything you want to say in closing comments, Paul? Any resources you might want to point to, or Cloud World tips or anything like that you might be?
Oh yeah.
Yeah.
That's a good point. I should be plugging Cloud World that we're doing. But yeah, Bo English and I are doing a presentation on MLOps at Cloud World. Yeah, exactly. Yep. And of course, any questions after that, everyone's free to contact on and I'm on LinkedIn as well too, if anybody wants to contact me there, of course. But yeah.
Well,
Yep,
I will close down the session now. Thank you everybody for attending. I hope that was valuable for you, and stay tuned for the next session of Multicloud Happenings. Thank you so much, Paul, for being our guest today. It's always amazing collaborating with you. Thank you.
Likewise. Thanks, Suzanne.
Thanks. Take care, everybody. Bye-bye.